Okay, continuing on with lesson 2.3. So what we found out here is that if p at x is the multiplication of some function times another function, f times g, then the derivative will be the derivative of f times g plus f times g prime. In Leibniz notation, if we have functions u and v, and they're both in functions of x, so it'll be like u equals some stuff with x, and v equals some stuff with x, then we would say that the derivative of u times v in terms of x is equal to the derivative of u in terms of x times the original function v plus the original function u times the derivative of v in terms of x. And we're still just getting used to this notation. It probably still makes you a little uncomfortable, but that's okay, you'll get there. Sometimes you're going to see me use a shorthand. Now this shorthand is not like an official mathematical notation, so you shouldn't use it within an official solution, but sometimes I'm going to just shorten this up by getting rid of all the brackets and the x's. So it would just clean up to f prime g plus fg prime. Or similarly down here, to clean this one up, we could just say u prime v plus uv prime. And so again, we won't use that notation officially. In our first example, we're going to use the product rule, and we're differentiating. We've got one function here. I can think of this function as f at x, and times a second function here. I can think of this function as g at x. Now notice it's something with x's times something with x's. If I just had a constant multiple out front, I would use my easier rule of just leaving the constant multiple out front and taking the derivative of the second thing. But no, I've got something with x's times something with x's, so I'm going to use my idea that I'm going to take the derivative of the first thing times the second thing plus the first thing times the derivative of the second thing. So to find h prime at x, I'm going to work my way through this formula. I'm going to take the derivative of the first bracket, and we know that the derivative of that first bracket is just 2x, times the second bracket. I'm not changing anything. So I've done the f prime now, I'm moving on to g, and I'm just copying it down as it is. So now I'm done the g, and now I'm going to add the original f. So I'm not changing anything, just copying it down. So I've got the plus, I've got the f, and now finally I need to take the derivative of g. So taking the derivative of x to the power of 3 is 3x squared, and taking the derivative of minus 6x is just negative 6. And finally, we're done the product rule. So then the next part here is we need to simplify. So when I simplify, the first thing I look for is there a common factor? So there's the first expression here, and then they're separated at the plus sign, and then the second expression. There's no common factor there for me to take out. So what I'm going to do is actually expand this 2x into the bracket, and then I'm going to FOIL this out. So I'm going to take the x squared and multiply it in, and then I'll take the 9 and multiply that in. And now I'm going to collect like terms. And I end up with, this is just a form of a quadratic, so I could check here to if this factors. Remember here, x squared, or x to the power 4 is just x squared squared, so it is just still a quadratic, but this guy does not factor. So I'm done. Okay, next question we're looking at is the extended product rule. So we're going to come up with a rule. What if I have 3 things being multiplied together? How would I find the derivative? So in order to come up with this rule, I'm just going to glue these second 2 things together and treat them as if they were one as I get started. Now I know that my regular product rule, so now I've got f at x times this bracket. So I take the derivative of the first thing and leave the second thing alone. And then I add, right, I'm just going through my regular product rule. This time I leave the first thing alone. And now I'm going to take the derivative of the second thing. Now, in order to do this, to take the derivative of the second thing, it's actually a product inside there. So I'm going to use the product rule again, and now g at x is my first thing, and h at x is my second thing. Everything else is just kind of staying the same. But now I'm going to take the derivative inside the bracket here. So g at x is my first thing, h at x is my second thing. take the derivative of the first thing, multiply it by the second thing, and then add, leave the first thing alone, and take the derivative of the second thing. And that's just my regular product rule. So now we're going to simplify and see if we've got some sort of pattern that will help us go right from multiplying three things to the derivative. So I take the derivative of the first thing, multiply it by the second and the third. And now here I'm going to multiply this f at x into the bracket. So I'm going to have f at x times this first term and then f at x times this second term. And then f at x. So I'm only multiplying each term. So once I hit a plus sign, I need to multiply by f at x again. And hopefully you can see the pattern here. Each of these three terms, there's three expressions that are being added. Each of them has three parts. They include the f, the g, and the h. But in one of them we take the derivative of f, in one of them we take the derivative of g, and in one of them we take the derivative of h. So when there's three things being multiplied, there'll be three pieces, and I'll take the derivative of each of the three expressions in each of the three pieces. All right. Another thing we might want to look at is what happens when there's a product. So what if instead of multiplying f times g, it's g times g? So here I've got g at x squared. So that's just g at x times g at x. So we're going to come up with, well, what is the derivative? And maybe there's a shortcut when there's a squaring on a function, and that's what we're looking for. So the regular product rule says take the derivative of the first thing and multiply it by the second thing, and then add. This time we leave the first thing alone, and we take the derivative of the second thing. And what we notice here is these guys are actually exactly the same. It's just that the multiplication is in a different order, but that doesn't matter. So I actually have two of the same thing. And so I'm going to write it as 2 times g at x times g prime at x. So I switched the order of this first one. So what I notice here is I had g at x squared, and it turned into 2 times g at x to the 1, and then times the derivative. So the shortcut here is to take the exponent down to the front and subtract 1. So you could think about there being like a little 1 on this one, and then multiply by the derivative of what was ever inside the bracket. So we're going to do that over here. We'll try an example. I'm going to bring the exponent out to the front, leave the function inside. That's what this is saying here. Leave it alone. And then here we take the derivative of it. So brought the 2 out, left the function alone. You can think about there being an exponent of 1 here. And now I'm actually going to take the derivative of that inner function. And that's 2x. And the derivative of the 3 would be 0. And then, of course, I can simplify that. I'll bring the 2x to the front and multiply it by this other 2. And it's already factored. I don't want it to be expanded. I prefer factored form. All right, so what happens if there's a 3 on the function? What's going to happen when I take the derivative of that? So that means that p at x is g at x times g at x times g at x, and we have that extended product rule. Remember that the extended product rule told me that the derivative is just going to be take the derivative of the first thing, multiply it by the other 2, plus leave the first one alone this time, take the derivative of the second thing, leave the third alone, plus, I'm going to have to go down a line, I'm running out of space. This time we're going to leave the first 2 alone, oops, and take the derivative of the third thing. But really, all 3 of these are the same. There's 2 g's and a g prime, 2 g's and a g prime, 2 g's and a g prime. So what I have here is 3 of 2 g's. Now instead of writing out the 2 g's twice, I'm going to say g at x squared, and then times a g prime. And so what happened here, if I want to go straight from the question down to this, I took the 3, the exponent, I brought it out front, and now it's a coefficient, and I subtracted 1 from the original exponent. Then I multiply by the derivative of whatever was inside the bracket. So let's try an example. We've got this function inside the bracket, and we're cubing it. So p prime at x, I'm going to bring the 3 out front leave the function alone, subtract 1 from the exponent. And now I'm going to multiply by the derivative of the inner function. So taking the derivative inside will be 2x minus 4, and the derivative of 5 is 0, so I don't need to write that. And the only thing I would do here to clean this up is just change the order again so that the biggest exponent is coming here at the end. That's just a nitpicky thing. I probably wouldn't take off a mark here because I still have everything with no x's at the front. All right, so what happens then? We're going to do a guess here. What do you think might happen if I've got the power of 4? And hopefully you can see the pattern here. To take the derivative of this, I would take the exponent out front, leave the original function inside, and subtract 1 from the exponent. And then at the very end, multiply by the derivative of that inner function. We call this the power of a function rule. And later on in lesson 2.5, you're going to find that this is very similar to the chain rule. It's actually the chain rule with powers, is another way for me to think about this one. The chain rule actually applies to way more different types, and that's why I'm specifically calling this one the power of a function rule. So the power of a function rule says, if I have p at x and it's some function raised to the power of n, then to find the derivative, I bring that exponent n out front, it becomes a multiplier, leave the original function, and subtract 1 from the exponent, and then at the very end, take the derivative of that inner function. In Leibniz notation, if u is a function of x, then to take the derivative of u to the power of n in terms of x, I take that power n, bring it out front, and then leave the original function subtracting 1 from the exponent, and then I take the derivative of that inner function u. Okay, so we're going to try some examples here. When I take the derivative of this first one, this is a little bit gross because it's a product rule. I have something with x's times something with x's. So this is a product rule, and within the product rule there's some chain rule stuff happening. Okay, so we've got our two parts. I'm going to think about this as like u and v, and so remember that the product rule tells me, and again this is just like my rough thinking up here, I wouldn't include this in my formal solution. The product rule tells me that I'm going to do u prime v plus u v prime. So taking the derivative of u, the first thing, it's a power of a function. So I'm going to take that 2, bring it out front, leave the bracket alone, and subtract 1 from the exponent. And then I'll take the derivative of the inner function. So taking the derivative of 1, that's 0, and taking the derivative of negative 4x, that's negative 4. That is just u prime. So we still got a lot more to go here. Next we're going to write down, we're just going to multiply by v, the original v. I'm not changing anything. And then we'll add. So now we're done the v, we've got the adding. We're moving on to just copying down u as it is and not taking the derivative. So copying down u. All right, we've got u now. And now we're going to move on to v prime. So taking the derivative of v, again, it's a power of a function rule. So I've got that exponent on the outside. I'm going to bring it down as a multiplier. And then I'm going to rewrite the original function, but I'm going to subtract 1 from the exponent. And then I'm going to take the derivative of the inner function. So the inside bracket, what's the derivative of that? The derivative of 1 is just 0, but I can take the derivative of 5x squared. I bring the 2 down and it becomes 10. X to the power of 1, or just 10x. Okay, so now we're going to try and clean this up. And when I clean this up, I'm not going to expand. Think about multiplying all of this out. You have 4 of these brackets here, times another bracket, and then times these 2 coefficients. It's going to be a huge mess of algebra, and to try to factor that out, you would have to use long division a whole bunch of times. So we do not want to do that. Do not expand. Instead, we want to factor. Remember that the easiest type of factoring, the factoring that we always start with, is looking for a common factor. So my function here splits at the plus sign, and I've got one term here and a second term here. I'm looking for what's in common between the two terms. So I'm going to start with just the numeric multipliers. So I see here that there's a 4 and a 4, so I can definitely pull that out. But also with the numeric multipliers, there's a 2 here, and I can pull a 2 out of the 10. So there's actually a common factor of 8 in both of these terms. So I'm going to pull that out. Next, when I keep looking, what I notice is that there's this 1 minus 4x bracket here, and there's 2 of them over here. So I can take one or divide one of these brackets out of each of these terms. And then again, when I look, I see that there's this bracket here, 1 plus 5x squared. There's 4 of those brackets here, and there's 3 of them over here. So I can divide 3 of them out of each term. Whew. So there's a lot of common factors. So we're going to get started. The first common factor is going to be negative 8. I'm going to pull out the negative. That's the yellow part. Then the next common factor is 1 minus 4x. And it's the power of 1 because there's only 1 here, so that's the most I can divide out. And then looking at the blue, the most I can take out is 3 of those brackets. Okay, now remember this is the common factor, so now we need to write out, well, what's left over after you divide it out. It's kind of like if you had like 8x plus 20, right? You figure out that the common factor is 4, and then you open the bracket to tell me what's left over when you divide each piece by 4. So it's a little bit more complicated. We've got a big thing instead of just a 4. But now we need to figure out what's left. So just looking at the yellow part, I'm dividing out negative 8. And actually, it used to just be negative 8, so I get 1. And then we move on to the green part. I'm taking this green part that was original and I'm dividing out one of them. And again, it's exactly the same, so I'm left with none of them, or just a multiplier of 1. And then last, I had 4 of these brackets. I'm going to divide out 3 of them, which tells me that I am still left with 1 of these brackets. Ooh. Okay. Next, we're going to move on over here. I'm going to look just at the yellow parts first. I had 40, and I'm dividing out negative 8. So I have negative 5 left over. There's also this x here who's just kind of hanging out. There was no common factor there, so he's still there. I'll put him next. Don't forget about him. You could even highlight him in a different color if you want. He had no friends, no other matching multiples. Okay, so we've done the yellow part. We've got the purple that was just kind of tagging along. Now we're going to move on to the green. So I had 2 of these brackets. I'm dividing out 1 of them. So there's still 1 left. And then looking at the blue, I had 3 of those brackets. I divided out all 3 brackets. So I'm done. And so now it's looking way better. It's already factored out front here. All I have to do is clean up this inner bracket. So I've got 1 plus 5x squared, and then I can multiply this negative 5x into the bracket. And I see that there is a common term that I can collect. And there I'm done. I asked myself about factoring this bracket. It's not going to factor for me, so I'm all done. All right, next we're going to work on part B. Part B said y equals, and again, I've got 2 things with x's being multiplied. So I'm going to think of this root function as f, and I'm going to think of this bracket as g. Now, one of the things I might want to do right from the beginning is rewrite this. So instead of a root, I have an exponent. So the square root is the same as x to the 1/2, and then I'll just rewrite that bracket. This is my original function. I am going to use the idea of f prime g plus f g prime because I'm multiplying 2 things and they both have x's. So I'm going to work my way through this. First thing I'm going to do is take the derivative of the f function. So taking the derivative of x to the 1/2, I bring the 1/2 out front, and I subtract 1 from the exponent. That's the f prime. Next I move on to the g. I'm just copying down the original g. Oops. And then I add. This time I'm going to write down f just as it is. You could change it back to a root if you want to. Eventually we're going to. And now I'm going to take the derivative of g. So we've got the f. Taking the derivative of g, I'm taking the derivative of the bracket. And so I've got 6x squared plus 4 when I take the derivative of that. Now, when I simplify my questions, I know that to simplify, I can't have fractional exponents, and I can't have negative exponents. I know that I always want to try to factor. And the other thing is if I have two fractions, then I will add or subtract them. So it's like using a common denominator. So let's see what we've got here when we're simplifying. Right away I notice I've got some fractional and negative exponents. So I'm going to rewrite those. This first one here is negative and fractional. So the negative tells me to move it down to the denominator. There's already a 2 in the denominator. It's just going to join it. And instead of a 1/2, it'll be a square root. You could also, instead of writing a 1, this whole expression here is going to join it on the top, right? It's in the top. There's no negative exponent. So I'm going to do that. Joining it. And then over here, I've got the square root of x times this bracket. Okay, so now what I have is a fraction plus, and you could think of this as another fraction, it's over 1 right now. So because I have those two, like at least one fraction added or subtracted with something else, I need to put them together. So in order to do that, I need to use a common denominator. That tells me I'm going to multiply this guy by 2 root x on the bottom, and so I'm going to multiply by 2 root x on the top. If you saw it, then you could pull the common factor of 2 out at this stage and cancel it with the denominator, and then you would only multiply by root x over here. I'm going to keep going with this. It's all going to work out at the end of the day. So what I've got now is 2x cubed plus 4x minus 6. And over here, when I multiply the root x times the other root x, that just turns into an x. So what I've got actually is plus 2x times the bracket. And that's all over the common denominator. Then I can multiply the 2x into the bracket. And now I'm going to collect like terms. And at this point, hopefully you see there's a common factor. If you didn't see it before, we're going to pull out that common factor of 2. And cancel out those common factors of 2. And so you're going to see that sometimes the simplifying looks really big on some of these questions. I'm okay with you leaving the root in the denominator, by the way, with the root x. I know in advanced functions that was a thing. When I'm marking these questions, I want you to remember that my main thing here is your derivatives, right? So there's actually a lot of marks in this first line, and then only a couple of marks, even though it looks like a lot of work, there's only a couple of marks here at the end. So really focusing on getting the derivative correct, and then the simplification is just kind of tidying up. All right, have fun with your homework.